trying to show you one or two things pertaining physics. What we'll be discussing about will be the introduction of physics, what is called dimension under introduction of physics. Dimension is very simple. So I would like you to look at the video, focus, and see the way we are solving when it comes to dimension. The question says derive the dimension of the following: energy, power, momentum, pressure. But before then, we have two types of dimension. We have the mass, the length, and the time. And they are represented with big L, and capital letter T. So while going further, energy. I know that energy is equal to the ability to do work. Normally, the SI unit for energy is in joules. But we are told to look for the dimension. To look for the dimension for energy, you know that energy is equal to force times what? Times distance, which is the work. And I know that force is equal to what? MA times what? Times distance. Now, if you look at this, I will need to bring in their SI units. Mass is kilogram, acceleration is meter per second square, times distance is in meter. I should take it the multiplication, I'll be having kg m squared x minus 2. Therefore, I'll bring in my what? My parameters. Therefore, I'll be having big M, I'll be having L raised to the power 2 and T minus 2. Simple. This is for energy. Let's go to power. We know that power, the SI unit for power is in watts. But what is power? Normally we say power is what? Energy over what? Over time. So I will proceed by saying energy, we say is work done, work over time. Therefore, I can still say force times distance over time. Let me bring in the MA times D over time. Let me bring in the SI units. I'll be having kilogram meter per second times meter over what? X. Let me multiply the numerator. I'll be having kilogram meter square x minus 2 over x. Now place this place. I can still write this as kilogram meter square x minus 2 times 1 over x squared. If I should multiply it, I will go back to this. So there is a law, that's law of indices. Remember law of indices, we say a raised to the power minus 2 is the same thing as 1 over a raised to the power 2. A raised to the power minus 3 is equal to 1 raised to the power a raised to the power 3. So for me to write this, I can represent this as kg m squared x minus 2 times x minus 2 times x minus what? Times x minus 1. Therefore, if I should go into it, I'll be having kilogram meter squared x minus 3. And that is the. Then I'll proceed to momentum. Momentum is the product of mass times velocity. SI unit for velocity, SI unit for mass. SI unit for mass is kg, SI unit for velocity is meter per second. If I should bring them together by multiplication, it will be ms minus 1. I'll bring in all the dimension parameters. It will be pm, it will be l, then it will be t minus 1. This is for momentum. Let me go to pressure. We're told that pressure is force over area, force per a perpendicular area at a particular period. If you look at this pressure, normally it's supposed to be in Pascal, either in Pascal or Newton per meter square. but we're told to look for dimension. So I know that my mass, my force is what? MA over what? A, area. I'll bring out the SI unit. This will be kilogram meter per second square. Area will be meter times meter. This meter will cancel this meter. Therefore, I'll be having per kilogram per second square over meter. Like I said in the other part, I can still write this as times 1 over m. Therefore, if you should look at this very well, I can represent it as kg x minus 2 times m raised to the power minus 1. When I come multiply both sides to be kg m minus 1 m minus 2. Please viewers, if you look at, then I will now bring in my dimensions by saying capital M, L minus 1, C minus 2. Thanks for watching. This is simply the easier way for you to solve when it comes to dimension. Have a nice day.